this lesson is going to be on multiplying and dividing complex numbers, which a complex number just means that it has a real number portion of it and an imaginary number portion of it. So you're going to see the letter I showing up a lot, which you guys should know about I from previous lessons. And in general, you should know your 4 basic powers of I. So we've got I squared, I cubed, and I to the 4th. And I mean, I know for my classes, I do my little, I won, not in the middle. You might have learned about kind of a circle method where you put your powers of I around, here, 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 and here. Same type of concept, but you need to know your 4 basic powers of I. In general, the most important one that we're going to be using a ton throughout this lesson is the fact that I squared is -1. Okay? So just like we did with the problems that involves radicals, we're going to distribute these problems that involve I the same exact way you would with a radical. 21 would be our first term, 6I would be our middle term, 35I would be the next term, and 10I squared would be the last term. Now we've got some like terms. 35I and 6I gives us 41I. And then hopefully you're seeing that I squared and thinking, oh, I know that I squared is -1. So now this becomes positive 10 times -1, which is a -10. And 21 minus 10 is 11 plus 14I. So they're really all that simple. Don't really think we need to spend a ton of time doing these because they're all basically the same. You're just going to distribute. Make sure you simplify that I squared as a -1. So I'll give you the answers for B and C if you'd like to try them on your own time. 6 plus 22I would be B, and -17 minus 17I would be C. But again, you're just distributing, combining your like terms, and simplifying that I squared to -1 to combine those real number parts. Okay. Now what do we have in number 2? We're going to find more products, which is exactly the same as we did in number 1, but if you notice, the 2 binomials that we're multiplying are pretty much the same exact binomial, but one's a plus, one's a minus. We talked about these in the last lesson. Those are called conjugates of each other. And just like they did with radicals, the conjugates are going to have some special properties with the complex numbers as well. So let's look what happens when we distribute. We get 16 minus 8I plus 8I. And the last term, positive times a negative, 2I times 2I will be 4I squared. Now, what's nice about this, middle terms are negative 8I, positive 8I, they cancel. I squared, just like we talked about before, is -1. -4 times -1 is positive 4. And look at the answer you get. We no longer have an imaginary part of this complex number. It's just a real number. And in this case, positive 20 is our answer. So same thing is going to happen for B and C because those are also conjugates of each other. Again, if you want to try them on your own, you absolutely can. Answer for this one would be 26. Answer for this one would be 45. Okay. And just like we talked about in number 3, it says what's true about each of the products that you found in exercise 2. All of the products that we found in exercise 2 are all real numbers. Okay. There's no imaginary part. And that's going to always happen when you multiply something by its conjugate. So let's skip to the back and actually do some of the problems dealing with having an I in the denominator. Having an I in the denominator is exactly like having a radical in the denominator because, like you guys should know about from earlier in the class, you should know that I is equal to the square root of -1. So this really is like 4 minus 5 times square root of -1. It's the same as having a radical in the denominator. We just don't keep square root of -1. We start calling it I. So if a division of complex numbers is consistent with the division of a real number, if we divide something by itself, it's really the same as dividing or multiplying by 1. So let's see, in B, write the original quotient in simplest a plus bi form by multiplying it by the fraction in a. Okay, so we're going to use this fraction, just like we did with the radicals, to simplify this expression here. And the reason we're using 4 plus 5i is because 4 plus 5i is the conjugate of 4 minus 5i. So we're using the conjugate of the denominator, but if we multiply the denominator by 4 plus 5i, we need to do the same to the numerator. Okay? Just like we did with radicals. And just like we did with radicals, we're going to have to distribute. We're going to get 12 plus 15i plus 8i plus 10i squared. And I don't like the way this I is looking. Kind of looked really weird. Over, in the denominator, this should work out a little nicer because they're conjugates. 4 times 4, 16. I know the outer and the inner are going to cancel because they're conjugates. Minus 25i squared. We have some simplifying to do now. In the numerator, whoops, a little too far there. In the numerator, we've got these two terms that we can combine. But also, this 10i squared is really a positive 10 times a negative 1, which is really negative 10. 12 minus 10 is going to give you 2. 15i plus 8i is going to give you 23i. Same thing here. This is really negative 25 times negative 1, which is going to be a positive 25. 16 plus 25 is going to give you, let's see, 25, 30, 41. Now, just like we did before, you can only simplify if all three of those terms are divisible by the same thing. They're not, but the difference here that we didn't have to do with the radicals is you have to answer these in a plus bi form. So we need to make sure that the a term is in one separate space from the b term, and then I is written at the end. So our a term is really just 2 over 41. This is in fact a plus. It could be a minus, but in this case it is a plus. Our b term is 23 over 41. And then I goes at the end. Now, if either of these individual fractions can be simplified, then you can simplify those. But in order to simplify from here, all three of the terms needed to be divisible by the same thing. So we'll do one more together, but I think once you can do one of these, you can do any of these. So let's maybe, oh, bells ring, jump down to, let's see, we just did one where we multiplied by a plus. So we'll do 5a, keep going in order. Here, multiplied by the conjugate, 5 plus 3i. When we distribute in the numerator, we're going to get 10 plus 6i minus 20i minus 12i squared. Denominator, 25. Outer and inner will cancel because they're conjugates. Minus 9i squared. Got some simplifying to do now. So these can be combined. This minus 12i squared is really a negative 12 times a negative 1. It's going to become a positive 12. And 10 plus 12 is 22. 6i minus 20i is negative 14i over. This minus 9i squared is really negative 9 times negative 1, which is a positive 9. And 25 plus 9 is 34. Now here, you can see that all three of these terms are divisible by something. In this case, they're all divisible by 2. So we're going to get 11 minus 7i over 17. But again, you've got to make sure you answer in a plus bi form. In this case, your a is 11 over 17. Little different here because our plus is not actually a plus, it's a minus. And then our b term, 7 over 17, I. Okay. And again, if either of these fractions could be simplified, then you can go ahead and simplify them even further, but in this case, they can't. If you guys want to try b and c on your own, answer for b, 1/2 plus 2i. Answer for c, 2/5 minus 11/5 I. And then same thing with, well, actually 6 is a little different. Let's look at 6. Which of the following represents the reciprocal of 3 plus 9i? I'm hoping that you guys remember what a reciprocal is. Reciprocal means instead of 3 plus 9i, we're going to look at 1 over 3 plus 9i. Problem is we can't leave that as our answer because we have I in the denominator, which is the same as having a radical in the denominator. So, just like we did before, we would have to multiply by the conjugate. Numerator is easy. This is actually an easier problem than a lot of the previous ones. 3 times 3 is 9. Outer and the inner will cancel. Minus 81i squared. So 3 minus 9i. Over, this minus 81i squared is a negative 81 times a negative 1, which is positive 81. And 81 and 9 is 90. Now, just like I said before, if all 3 of the terms are divisible by the same thing, you can simplify. In this case, they're all divisible by 3, so we'd get a 1 minus 3i over 30. And then we can simplify our answer into a plus bi form. My a term is 1 over 30. My b term is 3 over 30i. But kind of like I mentioned before, sometimes when you get to this part, when you do a plus bi, one of the fractions can actually be simplified even further. In this case, 3 over 30, well, we're not going to really leave that. We'll make it 1/10, which that's going to get us to answer choice 3. Okay. So if you can rationalize when there is a radical, it's the same type of concept when you have a complex number or I in the denominator. So that's it for rationalizing complex numbers. We also did some review of multiplying complex numbers. So this in general got you a little bit of practice on a couple different topics. Okay, that's it for today. Okay.